los estudiantes que están por ahí se vayan preparando porque hoy me está haciendo yo unos vídeos.
Is the Nano Thursdays spin-off talks, and we have today a speaker from Portugal, and company is Nano Energy, and he's a physicist, and Clara Marquina, who is also a physicist in our Institute of Nanoscience and Materials in Aragon, is going to present our speaker today. So welcome everybody, and Clara, you can go ahead and present. Andre.
Okay, thank you very much, Reyes. Well, first of all, I would like to thank you to the organizers of this nano spin-off series of talks for giving me the opportunity to introduce to the audience the speaker of today, Dr. Andre Pereira. Well, I have known, or we have known Andre already for many years, already since he was a student, PhD student. And we have collaborated with Dr. Andre Pereira along several years. And well, he is a very good friend also of us. And in my group and other groups, several groups at the Institute of Nanoscience and Materials here in Zaragoza. Well, just to start, a short biography of Andre. Well, he is a doctor in physics, and he got his PhD at the Faculty of Science of the University of Porto in 2010. Well, Andre is now assistant professor in the Department of Physics and Astronomy of the University of Porto. He's also assistant researcher at the Institute for Physics of Advanced Materials, Nanotechnologies, and Photonics of the University of Porto. And he is as well a visiting academic member of the Imperial College of London in the United Kingdom. Well, when Andre joined the Faculty of Science in Porto, at the University of Porto as professor, he was hired to work in the field of physical engineering, and also he was hired to promote the establishment of partnerships with companies. Andre participated in the Repsol Entrepreneurs Fund in Spain. He participated also in the European Space Agency Business Incubation, in the University of Porto Business Ignition Program, and in the University of Porto Technology Incubator Startup School. And also he participated in the IUP 25K, which is a contest about innovative initiatives at the University of Porto. In this contest, Andre got several awards recognized in the business area. Well, Andre is also co-founder of the Nano Energy spin-off, which is dedicated to the development of energy harvesting products for the use in the oil and gas industry. Well, I have to add that Andre is a very hard worker. He puts a lot of energy and enthusiasm in everything he does. So I think he will give a very nice talk about his experience of being a physicist, scientist, and going to the world of companies and business, and to start a spin-off company. So Andre, I think you will enjoy his talk, and yeah, Andre, the microphone is yours.
Okay, thank you, Clara, for the nice presentation. Okay, I hope that I will be on the expectatives that you implement, okay?
Sure.
And and it is also good to be here with friends and our colleagues and remember all the collaborations and all. And when you say that I was, we know since a long time ago, it was, I think it was 2005 or 2006. And I was
Yes.
really a young PhD student
Yes,
or starting
yes.
a PhD student.
Joining
So I will share
a European network, the training network you can hear.
yeah. But we will see that life is funny, and you'll see in my presentation some interesting things. Okay. So good afternoon, everyone. So like Dr. Clara Marquina presented, it's a pleasure to be here on these nano spin-off talks. I think that is a very interesting initiatives that should be done more. Okay. And today I will be speaking about bridging the gap between academy and business. So at the beginning, the invitation was to speak about the company, A2B Energy, but I thought that could be interesting to give the perspective as academic, as business, and try to see how things match and how the thing appears and if it is natural or not natural. So at the end, I hope that everyone enjoy the presentation and learn at least a little, okay? I tried to be also like a kind of educational. So this is the outline of my talk, okay? I will start, typically I don't do that, but I think that to contextualize the talk, I think that I need to talk about me, about a brief motivation about my scientific pathway, because the pathway will explain why I just, like say, did a deviation and go more on this trend. I will focus on projects between academy and industry, because this is a good perspective then to think about being entrepreneurship. Because if we understand and we discuss and we understand the language, then it's more easy to be entrepreneurship, okay? And give the pathway innovation towards a product. So giving a practical example from starting until more or less, let's say, a prototype near being applied in the market. Okay. So about me, yes, I start my research in 2005, 2006. I did a PhD on Porto University in physics, and it was with a strong collaboration with Saragossa University. So that's why it's very proud for me to be here presenting and remember these times that we were when I was in the Saragossa University. I went and I work with magnetic materials, as you will see afterwards. Then in 2010, I finished my PhD and I went as a postdoc at Oak Ridge National Laboratory. Okay, it was a mix postdoc, so I was 6 months in Oak Ridge, 6 months in Oporto. During 3 years, I did that, and then thinking on finishing almost my scientific research, I decided to do a break, and I went to Imperial College. I was very well at Porto University, but then I was like, let's push the limits of myself as researcher, because motivation about having only articles and all this stuff was like, let's say, disappearing. I went to Imperial College. There I was research associate only for 1 year. Because then I have the opportunity to return to Porto University. And during this stage, let's say that I did at Imperial College, my way of thinking changed a little, or let's say even a lot. So it was more focused on practice and doing the devices and so on. And then in 2015, we found the A2B Energy, a company, and this is more or less the things that I did like in my pathway. But important more than this is what I learned on this, okay? So first I work on the field of magnetic refrigeration, and it was very focused on understanding the material for magnetic refrigeration, okay? It was about phase transitions, about the properties, electrical properties, transport properties, but it was very focused on characterization of the materials and understand very well the materials. In in parallel, during my PhD, I also work with magnetic nanoparticles, understanding well the magnetism, understanding the effect of frequency and all this stuff. And also in the field of magnetic refrigeration, I learned how, for instance, to measure the magnetic elastic properties. And Clara was one of the persons that introduced me to that about magnetostriction, okay? Then I start going more for application. So I start working on thermoelectrics. This was on the field when I changed to a postdoc for being more applied. So again, materials and all this stuff. But then when I came to Porto, I start the field of triboelectrics and changed the idea of thermoelectrics and start working more in energy harvesting and applying the energy harvesting. So development of device, and more recently in 2006, I start also with energy storage, okay? So I could say that nowadays my main core is related with energy, is energy harvesting and energy storage. And these are my main core research on that, but still I have some parallel projects related with magnetism, okay? So what I learned with that? So a lot of things, fabrication techniques, physical vapor deposition, a lot of different techniques. Then I also, under collaboration, I start working and understanding what is co-precipitation, chemical of the polymers, solid state reaction, screen printing, stencil printing, and so on. Moreover, I understand about magnetism. So magnetization, magnetocaloric, magnetostriction, hyperfine, neutron diffraction, and all this stuff. Then also transport properties, Seebeck, electrical resistivity, thermal conductivity, magnetoresistance, electrochemical properties. And this more recently was with all these multidisciplinary core, just starting doing prototyping and testing. So with the knowledge and the multidisciplinary areas from fabrication, magnetism, transport, all characterization, changing and testing and prototyping device. And what was the goal? The goal, of course, it was to give new solutions for the society, okay? And this, I could say that nowadays, the research that I'm doing is much more related with that. So research being applied than doing research more fundamental, okay? Why? Because in fact, let's say that when I started doing research, at least here in Portugal, we were in a paradigm of methodology where scientific research and business should combine the strengths to accelerate the emergence of innovative products, okay? And with this aim and with this goal, we start thinking different, okay? And that's why the university contracted me. Why? This was like walking until you arrive to a mountain, because start thinking to do research combined with business and doing innovation and innovative products is like climbing a mountain. With that is combining, of course, the emerging field of nanotechnology, because it's always appearing and having new effects and so on. And so the idea was that in 2014, when I arrived, we need to start to spin off. So nano spin off, like you say about your talks. Okay, so this was the main idea that we have. So there are two options to do it. Okay, and these are the two main options that I will speak. One is working directly with companies or technological centers. Okay. And this is something that we do. And the other one is to be entrepreneurship, okay? I will start with the first part, probably the ones that is, let's say the mountain is more easy to go until the top, okay? So 4 things is very important that at least I learned, and I think that everyone knows, but we need to think more when we want to work with companies, okay? One is we need to be fast. You don't care about the way you achieve the main goal, okay? So 2-3 years for them is like a nightmare, okay? So you should really be fast to achieve the goal that they want on the project. Then they ask that, oh, I want a totally new innovation. Preferable, it should not have been in the market, okay? So it really needs to be new. The third one is low cost, okay? And this is always, as scientists, we typically say, oh, this is better and so on. They say, no, how much it costs? If we say that it's a very high price, they will say, no, it should be low cost. And the last one, and sometimes is one of the main problems, is the scalability, okay? Because sometimes you do the things, but then when you go to the scalability, the reproducibility and the effects and all the stuff that you are expecting to have is not as you wish, okay? And these are the four main, I think, main challenge when we speak with industry. So we need to speak about the language that they speak each day, okay? So then I will start speaking about some of the projects that I have and about the companies. One of the emerging, let's say, areas that everyone is talking about is about the Internet of Things, okay? Everything should be connected. Everyone wants to be in a click and just touch and do some action, okay? And one of the projects that we have is about risk assessment, okay? This is with a company, what they want to do. They want to do smart monitoring in real time on pipelines, okay? And what they want to see is corrosion and cracking. So they want to detect corrosion and cracking. Important is that they want to use a non-destructive testing, okay? And so this is a project that we are doing with them. And what is curious, and this is for Clarimarkin, is that this is based on magnetostriction. So you can see that this was one of the first techniques that I learned when I started. So the idea is that you just do an ultrasound perturbation in a tube, you send the sound with magnetic field, and then you see, for instance, the blockage or the corrosion or the cracking. You will have attenuation on your signal. So what we are doing. So the idea is that they have problems because the materials that they are using are bulk materials, and so when you put the pipeline is not well suitable, and so the contact between the tube and the magnetostrictive material is not easy. So what we are doing, we are preparing thin films of magnetostrictive material in a flexible substrate, okay? So here you have some of them, or in some cases we are depositing really in the material to make sure that the position of the material on the top of the tube, for instance, or of the thing that we want to study, the thickness or the properties, we deposit on the top and measure the results. And in fact, this is a very new results that we obtain using a flexible substrate. We were able to measure the thickness. Here is this is the emission signal, and this is the reflections coming from the thin film of magnetostrictive thin film. So we can see that nowadays they are under, this is a project ongoing, are under development, but what is good is that we thought that changing to a thin film, we were not expecting, for instance, for the same, for having effect, because it's a very small material, but in fact it seems that we win with contact and contact between the pipeline and the magnetostrictive thin film, which is interesting. Another important part, and this just to explain about the academy and business, is that we need to think that our neighbors are the best. And the neighbors near Porto University is textile companies, okay? So it's in the north. Porto is, let me put here the pointer. The Porto is around here, okay? And so the textile industry is very focused here in the north, okay? So the idea is that because having the companies very near the university, it's more easy to go there and see and discuss and have meetings and all this stuff. And so these kind of projects are, in my opinion, sometimes with better goals, okay? This is very important for Portugal because textiles, you can see here, this is around 7,000 million euros per year of revenue, okay? And you can see that we are talking about around 200,000 employers, okay? And if you think that, for instance, Porto region, we are around 1.2 million persons, you can see that the number, the ratio is quite high, people that works on textiles. This is more important when we compare with the European market, okay? Because when we compare to European market, you can see here that Portugal here is in the turnover, is in the number 6, okay? But in the number of companies, you can see that we are the 4th, and in number of the employment, we are the 3rd. So you can see that textiles are an important market segment for for our region, and very important also to Portugal. Okay, and so also on this area we are doing project with companies. Okay. One of the concerns that everyone are speaking about is about the 5G. Okay, no one's know really about if it is danger, if it is not danger. Why? Because the idea is that it's true that the wavelength are, let's say, the frequency are not so high. Okay, is around 2.6 gigahertz, maximum 3 point something. But the problem is that because they increase the velocity, they will put much more hotspots of the electromagnetic waves, okay? And with that, no one knows what will be the real effect, okay? This is something that even the World Health Organization is discussing about that. If you go there, you will see that they say, well, it's expecting not having problems, but still we need to do more studies and so on. Another way, there are kind of applications like fashion applications. At the beginning, like 5 years ago, everyone wants to have internet in the restaurants, for instance. But now there are some restaurants that they want to be shielded to the wireless to make sure that people are just get dinner in family, okay, without having mobile phone. And so also on this kind of protection, there are textile industries here that want to do this, to put in the windows and all this stuff to make sure that there are this kind of installation. Okay, so for that we start, and this was for starting. We prepare a measure setup. Okay, we buy a network analyzer. We have the cavities. We were able to measure the electromagnetic shield from 1.5 up to 18 gigahertz. Okay, and these are the classification that you can find. So you can find that for general use, having a shield effectiveness higher than 30 dBs is excellent. And for instance, for professional use, let's say 40 is the normal, but if you want really a big shielding, of course, you should go for the AA, which is above 60 dBs, okay? But what I want to say with this is that when industry think on physics, they never think about what we know, okay? And of course that they were saying, oh, okay, it's true, but how we can solve this? And I will explain. It was, let's say, more or less simple to do it, okay? Because what they wanted was above 30 dBs. So for that, we use a simple method like screen printing, okay? And just using, for instance, the silver paint. The problem in textiles is that if you cover all the textile with silver paint, well, it's not fashion, it's not modern, it's not breathable, it's not the lightweight, it's not so good, and so on. So what was the idea? The idea was like, let's start doing stamps, doing designs, and see how we do it. So what we did, this was the very first test that we did, we start opening and doing squares, okay? But more important than that, and this was where they were really surprised, was that we start simulating, because doing simulations means that we don't need to do all the stuff. So if you go to, like, say, to an engineering school, like a very basic engineering school, what they will do, they will print a lot of materials, they will test, and they will see how it goes, okay? On this case, on particular case, we did simulations, okay? So what did we did? We did 4 samples, we test, we did the numerical simulations, and here you can see, probably you cannot see very well, but I will do like a zoom. Let me check if I'm able to do zoom. But if you go here, you can see that the continuous line are the experimental results, and the dots are the simulations. And you can see that they match pretty well when you compare both. In this case, this was because the simulation was not so good as expected, okay? So what we see only with simulation, it was that if we wanted to have electrical magnetic shielding above 30%, we know that just by covering between 70% or 80%, we are above the class of AAAA for the normal user, okay? And this was surprising for them. What are the advantage? Okay, so reduction of costs, lightweight. We have more designs. We can do different designs to decrease that. They are more breathable, they are more flexible, and they use less material. So what I like to say is that sometimes things that could be easy for us, for them is very advantage, okay? And the company was really surprised with that. So we continue working and trying to put different kind of nanomaterials on to increase this shielding effectiveness. But in fact, it's something that they saw that it was profitable to work with us, okay? One of the last projects that we were working was about wearable technologies, okay? So like I told you, Portugal textiles industry are very important, but it's true that we cannot compete with China or with Turkey. So the difference is that we should go on technical textiles, okay? So let's say smart, wearable technology and all this stuff is the things that we are being main focus here in Portugal on the industry of textiles, okay? And so as you can see on this slide, you can see that there are different kind of applications. So you can, just by jogging, you want to have monitorization and all this stuff. It's true that you can use your smartwatch, but the idea is that you should have the wearable on textiles. In the military industry, there are a lot of applications that you can use these kind of things. For instance, stress is something that is very important to do the monitorization of the military, on medical field, or even in fashion, okay? And so there are one company that are focused on the part of sports and health for high competitivity, okay? So the idea is that they want to use the textiles, but one of the problems, and this can be very, very interesting, is that a problem is that if you use a battery, this has some weight, and in some cases weight is a problem, okay? So what they want to have is batteries that are embedded inside of textiles, okay? And this was something that we start working on, okay? So the idea was based on supercapacitors. They are increasing a lot the energy density in the last years. So we use screen printing techniques. We were able to print this type of device and the different configurations, okay? Here we use nanomaterials. Here you have textiles recovered with nanomaterials. And then you could see here that one of the things that you have a capacity of retention very high, more than 96% after more than 10,000 cycles. Charge, discharge, charge, discharge, okay? Then when you compare with the literature, where you have here the supercapacitors, the capacitors, the batteries, and fuels, you can see that here there are some literature, but I can say that nowadays, using the nanomaterials that we are using, we get let's say, energy density that are very compared with batteries. We are able, for instance, to put sensors just working during more than 3 hours or 4 hours, okay? Here there is a small video just to show how this worked. So this is a LED, this is the first test, and this was one of the first devices that we did, but this is something that we are doing. In fact, this was almost my second company, okay? And this is just to show how the things go. So the idea was, the innovation was good, and we were like a startup, a promising startup in the last, let's say, 3 years, okay? We win a lot of prizes, we were in the news, and in fact, they highlight this discovery as in 2018, the best scientific discovery of Portugal, okay? By one agency well recognized. But in fact, so since we have the opportunity, for instance, to work with a technological center, it was more easy to implement, and as you will see in the slides when I will discuss about the company, it will be more easy to implement and faster going by the scientific part, okay? By the technological center. Why? Because just to remember, and this, since we are pedagogic, when we are working with this kind of projects, we need to patent, okay? And one of the main problems first is who is the inventors, okay? Because you are working with the company, who are the inventors? And this is a discussion that I will say as advice, please speak since the beginning. This is like being married. You should say always the rules since the beginning. If not, the things will not go well. Then the process, okay? Because there are several stages, several phases, okay? You can see that first phase is almost 3 months, then we submit to the PCT, then we have a phase 2, which is around 12 months. Then we can send to European PCT, and then around 18 months, we will have the phase 3, and then let's say more or less after 2 years, we have the patent review and we have the patent, okay? And only after we can start discussing about selling the patent, okay? Licensing the patent to the companies. And so this is a thing that we need to think. And for instance, in our case, that's in some cases there are PhD students, we need to think, because until the patents don't be published, at least the student cannot publish the article. And so it's like a kind of equilibrium that we need to think. About this type of science and working like with technology transfer life cycle, we have here the several steps, okay? So research and development is the good, the invention, and evaluation. So this is more or less 3-4 years, let's say maximum, let's put minimum 3 years. Then we have the IP protect and the marketing, let's put more 2 years. Then licensing, product development, public use, and the economy grow is more 2-3 years. You can see that the life cycle typically is around 7 to 9 years, okay? And this is, of course, what if you speak with technological centers like the ones that we have here in Portugal, like Sentia, CITEV, they typically say that this is the normal. The faster that they have was around 5 years, okay? If it is like on this, and this is something that is not so good for let's say, for the industry, okay? Then there are another part, and this is more pedagogical, is about the licensing. Because there is a discussion between the university and the industry, and they should speak about the royalty sharing, okay? This is the typical numbers that we are discussing, at least here in the Porto University, and for instance, UT Austin and Imperial, it was more or less these numbers. 50% of the royalties goes to the inventors, then 35 is for the university, and after is more or less shared by the different players of the university, okay? So you can see that this can be, let's say, a long time, but sometimes we want to be faster, Okay, we want to go and reach the market faster. Okay, and what could be the strategy? The strategy could pass to be entrepreneurship, because then the rules is you that made. Okay, so the rules are controlled by you. But of course, that first you need to spin. Okay, you need really to change. Then again about nano, because it's emergent, and then, but then it's not working until you reach the mountain. You need to climb the mountain. Okay, so which is much harder. So you need to be fast. So you need to really be prepared for that. Okay, so it's really a different way of seeing science or living with things. So following this rule, in 2015, me, João Ventura, and Mariana Proença, we joined an adventure, let's say, and we decided to, with the things that we were doing, we should go on or as an entrepreneurship, okay? And we found the iNano Energy. As the name says, is innovative nanotechnology for energy, okay? What we do consulting, so looking to a real industry problems. We do the design of this for the energy harvesting, and for instance, we now are working also on Internet of Things, like putting the energy harvesting to the sensors, and then we do prototyping using cutting edge technologies, okay? One thing that we do is like about this energy harvesting is that sometimes is different from the other ones, is that we have a lot of methodologies and the knowledge. And so when we look to the problem, we first look for vibrations. And this is, for instance, you have a lot on cities. We look for electromagnetic. We look for instance, heat dissipation. And using this, we want to recover some energy, okay? So depending on the kind of applications where we want it, we are able to work with these three different kind of technologies. And in fact, we are able to hybridize the three technologies in order to increase the outputs, okay? We could say that methodology of iNano Energy is design thinking, okay? When I say design thinking, is that when you are working on this type of energy production, sometimes it's very hard to go to the market and say, so I have this solution, but then someone says, oh, but I want this variation and I want this variation and so on. And so the way that we work more is on design thinking. So the idea is that we empathize, so we try to understand the people. Then we start defining and figure out what is the problem. Then we came with a generation of ideas. We start prototyping and we start testing, okay? This kind of methodology, it takes longer, okay? But if it is well applied, okay, it can be very, very profitable, okay? Why we did this? Because at the beginning, and I didn't put here the slides, the iNano Energy was focused on shoes and textiles, okay? But on that stage, we were able to produce, as you will see, energy on shoes, because it's also a segment market important in Portugal, and on textiles. But telling the truth, we think that let's say the market, at least the national market, was not prepared for that. We were in advance. So we produced energy, but then they didn't know what to do with that energy, because the wearables and all this stuff is still going on research and is still going on development, okay? So it's something that we could not say that we can return, but tell the truth, we change let's say the field of our company to be more on design thinking. And this was when it appears Repsol, okay? So these are the 4 areas that iNano Energy are being working on design thinking: oil and gas, water management, blue energy, and waste management. And these 4 particular projects are projects that are very focused on design thinking. So we know what is the real problem and we need to solve the problem that they have, okay? And this, I say in advance, but this was when it appears Repsol. So in discussion with the technical staff from Repsol, and because they knew our company and so on, they came to us and say they have a particular problem. Is that when you have the platforms on the deep ocean and you are extracting oil and gas, the extraction in downhill is very hard to have monitorization, and cracking of the tubes and problematics as occur in BP, where the oil just goes to the ocean, it should be not occur, okay? And so we should monitorize. But one of the main problems that they have is to have energy there, because they can put batteries, for instance, but the problem is that to replace the batteries, they need to put a submarine, they need to go on the deep ocean, they need to stop the platform and all this stuff. So there is a problem on having energy in downhill. So it's a particular problem. And they try to ask us how to solve the problem, okay? What they want to do, they want to monitorize temperature, they want to monitorize the pressure, and they want to monitorize even the infrastructure if it's possible using this kind of technique like ultrasound. And important, just one thing, important is that for them, they could have just one signal each 2 days or 3 days, okay? So they don't need a lot of power, they just want to see if everything is controlled. It's not a really continuous monitorization where the sensor will be always working. No, it can be just in a few moments, okay? And this was when it appears, and we were working with triboelectric nanogenerators, okay? You can see here that the triboelectrics, one of the first papers starts in 2012, okay? And we start working on that at Porto University in 2014. So you can see that it was really in the beginning. And so with this technology and thinking that, well, this can be really interesting because the outputs were very promising, that's why to boost and to be faster to reach the market, we had the iNano Energy. We found the nano energy working on, let's say, the main innovative area. It was about triboelectric nanogenerator, okay? So since then, so this discussion with the Repsol, it was in 2017. Between 2015 and 2007, we were like in textiles, shoes, and so on. But then in 2017, we say, now we have a really problem, we need to solve it. So we went to Fundação Repsol, to the empreendedorismo progress that they have, and we start working on that. So what is this triboelectric? Triboelectric is a very known phenomenon that everyone knows, because even when we go, if you rubber a balloon in your in skin or in your I forget the name, but you will see that there is electrostatic energy, okay? And the idea is that we won't use this electrostatic energy. For that, we need to have a contact electrification and electrostatic induction, okay? So the idea is that you have the electric that typically wants to have a positive charge on the one surface, and the other way on the other, the electric that wants to have an opposite charge on the top. So when they contact, you just generate the electrical field, and with that you can generate energy if you put a load. So what allows the triboelectric nano energy? Higher power density, because, for instance, triboelectric scales with area, not scales with mass, okay? For instance, if we think on electromagnetic induction, it depends a lot on the amount of magnetic material that you have. On this case, you scale with the area, okay? And you can see that why nanotechnology is very important, because you can increase a lot the area of device. Then is a simplicity working mechanism. So it's just contact, release, contact, release, contact, release. So for vibration, it's quite easy to use. and is very flexible because we are talking about polymers, okay? And so you can see that, for instance, to recover tubes and all this stuff is very, very interesting. And there is a very wide range of available materials, okay? So here I show some of the materials that you can work. So you have positive, you have negative. Just to show, for instance, positive, you have human skin. For instance, you can produce energy just by touching on human skin. You can use polyamide, you can use PMMA, aluminum, paper, cotton, zinc, nickel, gold, another PVDC, PS, Kapton, PDMS, or PTFE. You can see. The idea is that you should choose the electric 1 and 2 at a different change. So one very positive and another one very negative. But then you can adapt if you have different, at least if the materials are at a different range of the charge, you will generate something, okay? So, of course, that nano is important. Here it was a study that we did using nanospheres lithography, and we were able to change the size between 2 micrometers to 200 nanometers. And for instance, you can see here that there are a kind of tendency that decreasing the diameter, you will have an increase of the power density and the output voltage, okay? And then if you go really nano scale, sometimes you have a reduction because they need to match pretty well. And so this is a problem that sometimes we have when we go really to nanoscale device. So then in 2018, we have the possibility to go to Repsol technology to start testing our devices, okay? In Repsol technology in Madrid, they don't have, let's say, a system that you can have a flux of the oil and gas. So the idea was to test just materials at that conditions. So we were able to measure statically the output voltage as a function of pressure and temperature. And what we saw, it was that we could increase the pressure, we observed a decrease of the outputs, but still we were able to charge capacitors, okay? Even for low signals, we were able to charge them. And so we were saying that we could operate at 120 degrees and under a pressure of 830 bar, which for them is very good because 80% of oil extraction, they are below these conditions, okay? So which means that our materials could work on that. Then we get a project at the Nano Energy that we were able to construct our test bench. So we were able to have a flow of fluid, oil and gas, with these parameters, changing the temperature and doing all the test chamber. You can see that these are really high pressure. So it was something that we developed in the company, and now we are suitable to test them. And by test, we were able to also produce energy with just by the flux of the oil and gas, okay? And the power that we were able for just a few centimeters, it was around 1.2 microwatts, which means that it's already some interesting output, namely for the different applications of IoT, because they are low power consumption, okay? But then we changed to the other part. So we went to, and this was in September of last year, we went to Norway to test in a company which is called XRIG to really test the materials under the conditions very similar to the ones that you can find on field. So this company is tested for this type of tests, controlling the pressure and flux and all this stuff, okay? And using them, we were able also to produce energy. It's true that we saw a reduction of the power output, but still we are able to produce, which means that our technology are able to produce energy under the conditions near the environment, okay? So why this is important? Because like you saw, this is a question of flexible materials. Is a very easy scalable technology. We use flexible materials and this is low cost because we are talking about some kind of polymers. And what is interesting on this kind of non-hole power generation is that we have kilometers and kilometers and kilometers of tube, okay? Why they don't use for instance, electromagnetic induction? I can explain that they don't use that because when you are extracting the oil and gas, there are a lot of stones and different kind of material, and it can block the fan. Okay, so that's why they need a different solution. And for now, this is the stage that we are, but Repsol still continues doing, let's say, accompanying our development and see how we can scalable. So in this field, the oil of gas, we have the typical table technology readiness level, where we can see where our technology it is. In this case, in this particular case, the TRL are only 7. Okay, it's different from NASA. Okay, so TRL1, you have demonstrated concept, 2 validation, 3 prototype, then the environment test, system tested. 6, we have the system tested, so it's installed, and then the field proven. So this is how we are. So 2017, we start with the TRL1 of formulation of technology, discussing with Repsol. Then in 2018, I show you, it was the materials tested and selected under the pressure and temperature. 2019, we start applying the research as a proof of concept, developing our FLOOP system. And then in 2020, we test, and we could say that we are between a TRL3 and TRL4 on this field, okay? And and now we are in TRL4 because we already test in flow condition and then environmental conditions, okay? So you can see that now is probably the biggest step that we need to give, because now we need to go to the field and start testing in the field, okay? And this is a question and is a problem, because in this kind of technology, the amounts are very expensive. I could say, just as a reference, 1 day testing in Norway, it costs around 8,000 euros, okay? And just 1 day. So you can see that it's really a lot, without other expenses like hotels and all the things. It was just to test, okay? Another field that we are working on is on blue energy for remote place. You know that Portugal, we have a lot of ocean. We are, I think, we are a very small country, but with a huge amount of ocean, because it's almost surrounding Portugal. And so this is strategic. So blue energy is something that they want for remote places, okay? So that's why energy harvesting appear on this. So on this field, this is an ongoing project that we are working on. So this is a buoy. This is a buoy that is scalable to the waves. So this is a simulation of the waves, and we were able to produce energy on that. Okay, and which is interesting to put sensors and have, for instance, to know what is the temperature, humidity, and send by GSM for the central, and to have access to the data. Okay. Another part, like I told, is the hybridization, and this is the kind of other applications. For instance, when you are running, you are doing pressure on your shoes, okay? And this was the type of things that we did. So we started developing prototypes to put in the shoes to produce energy for smart shoes, okay? Like I told you, since we know several technology, we were able to do a hybrid device. So we use triboelectrics. We joined the electromagnetic generation, and then we put piezoelectric on the top, okay? And we put on the shoes. Here are the outputs that we were able to have with that, we were able to reach around 30 milliwatts, okay, which is something like if you put an Arduino in a simple stage sending a value like by Bluetooth, you could only need this type of power, okay. Here is that during the walking, you could charge one capacitor. Here is the different technologies. You can see that piezoelectric is not well suitable on this case, okay. Probably the material was not the best of the under output, but we have here the electromagnetic and the triboelectric, and you can see that we have an increase by hybridization with our device that has the three solutions, okay. Here, just to show that you can walk and you can light LED, okay, but in fact you can charge a capacitor each time that you are walking, okay. Of course, that startups have needs financial part, okay, and this is something that I want to highlight, of course, because if I was a young student or finishing and I want to do a startup, I should see all these solutions that I told you. So you can see here the typical cycle of startup financing. So the first part, you have the seed capital, and the seed capital, typically you have a negative revenue, okay? And this is the first part, so you need to find seed capital. Then you start having the break even after the business angels, for instance, put money, and you goes to venture capitalists or acquisition merge or strategic alliance. And then you start having first stage, second stage, and then you can, which is called the early stage, and then you can go to third stage and the mezzanine, which is really near the market, okay, for the public market. And these are the stages that are important, and this is normal. All companies do that. In our case, we don't have any kind of capital invested, okay. The company only have been working about money from projects, okay, or some service that we are doing now. And what is the main constraint that we have? Why business angels, seed capital, and so on? Why is difficult in our case? Well, you know, you have business angels and we have the academy. And one problem of business angels is that when the owners are from a university and they have, let's say, established work, it's very high to believe that we will do a lot of work and we will work a lot on the company. Because what they want to put money, and then they stress us to reach the market, okay? And when we are already, like we have like a more stable, like in my case, João Ventura or Mariana, that we are professors at the university, it's more hard because what they want is that we just say, we will leave the academy and we will be 100% focused on the company, okay? And when we do that, it's very hard. When we start discussing, it's very hard to feel that. Or they just came and say, okay, we can give you the seed money, but you give us 80% of your company, just for you to feel that you need to work. And so this is the kind of things that I want to highlight, because it seems that everything is a dream, but then when we go to this type of things, typically is more confusing. So iNano Energy now, we are 6 persons, okay, working on. Me, João, Mariana, me and João, we share the CTO and CEO. It depends who is available, okay? We put this work like that we do, but in fact, we share the things. Then we have Katia with physics engineering, and she's doing a PhD between academy and the company. And then we have one mechanical engineering and one electrical engineering for working with us. Okay, so this is more or less what we do at High Nano Energy. Okay, this is our topic. We say that our energy everywhere. So in the middle of New York City, or in the top of Everest, or even in desert, and if we think even more away, in space. Okay, And when we say that, is really everywhere, okay? So the idea is that we want to produce energy in all places. So these are the main conclusions, okay, of the talk. I hope that I show you that academy is very important. Knowledge, be multidisciplinary, a lot of knowledge and all this stuff is important for us to have the background for the challenge that they give us, okay? Then we have the business part. Of course, numbers. This is what you need to think about numbers, how much money you have, what you will do, and you need to really to pay the persons you see, because it's your account that is paying. It's not our university that is paying salaries, it's ourselves that each month we need to pay the salaries to our workers. And I hope that I also show you that there are challenges between academy and business, okay? And that there are opportunities, okay? We need to think further for this. And I think that, for instance, the new European framework will be very focused on that, okay? For the future. Of course, that the part of the academy, I could say that, sorry. So of course, there are team and collaborators of the projects, the researchers, the PhD students, some collaborations here in Portugal. And ECTEV are two technological centers that support us a lot. And of course, the funding that we have between academy and the company, yeah, there are a lot of funding coming from that. So I finish my presentation just saying thank you. And it is always a pleasure to see the Cathedral of Saragossa, okay? And I hope that you enjoy. Okay, thank you.
Thank you. Thank you for the very nice talk. So thank you. You talk about many different topics, no, Clara?
Yes.
Many things.
No, I try to give a perspective about the all stuff, not being only focused on the company, okay? Just to show that sometimes, okay, we could present here the company and see all the sources and all this stuff, but showing what is the background, and this sometimes is important because sometimes people forget that, okay? Forget that there is a background, and we have a lot of to thank a lot to the academy for that, okay? And also the challenge. Sometimes there are a lot of challenges. So I don't know if there is more.
Well, there are questions from the audience for Andrea. Please turn on your microphone. Also switch on your camera, and Andrea can see you. So let's see.
So
I have a question, Andre.
Yes, correct. Okay.
Thanks a lot for your presentation. It's really it was really interesting. A lot of things, like Reyes said, many things.
Yeah.
And I'm doing the PhD here in Zaragoza about microwaves. So I was following maybe the first part of your presentation where you talk about the printing of metamaterials, if I will remember. About the simulations, you simulated just the distribution of the electromagnetic wave. True?
Yes.
And you consider also the presence, for example, of interference from the surrounding sphere, or it is in an ideal condition?
So this is the idea that we have behind. So the idea is that on this kind of projects, typically we try to solve the problem of the company, okay? And this was the first simulation. So what they wanted is like something that they could go and certify that they have 30 dB shielding with that kind of textile that they want to use. But then we have always the background of science, okay? That's why on this kind of project, I also put PhD students to do that, to study the interference. Yeah. So that's why we are using nanomaterials to see if we are able to increase the shielding effectiveness, even using less material or better material or different color material or multifunctional material and all this stuff.
It's interesting.
Okay.
And another question is, you print your design over the textile, and I saw that you test the different cycles of charge and discharge, and it was really stable. But for example, thinking on the use on an application, I think that it's also important to see maybe how the material can support the exposure, for example, to water if you want to wash the textile. No? If in this case, for example, have you done some analysis or some results?
So this is a very, very interesting question, Roberta. And that's why we have these technological centers to support us, to give us like a list of things that we need to test, and we do it. In fact, we test, okay? In the first time, we see some difference. And then it was when we start doing different kind of like encapsulations that they know how to do it, okay? To make sure that they are proof of water, okay? But one thing that is important, it's sometimes there are some applications that you just want to use once, okay? Just one t-shirt as once. And this is something that sometimes we forget. But for instance, like 10 grams for a high-speed person that wants to run 100 meters, okay, 10 grams, like a battery there, could give issues, okay? And so you just need something working just 10 seconds or 20 seconds. And if you are able to do it, and for them, one t-shirt is nothing because they have a lot of money. So Nike will offer t-shirts if they want.
If there is the market, no problem.
Yeah.
Thanks. I'm really interested.
But that's why it's interesting to discuss. That's why I always speak about technological centers, because they give you really the requirements. I put the main requirements about scalability, low cost, and all this stuff. But then these requirements that you are saying is something that we also learn a lot discussing with them. Okay.
Thanks.
Okay. Any other questions? The students, the audience, the people.
Even I can speak Spanish if they want. If it is a question of
your side.
From my side, I can speak. I see
Any
here
question on YouTube? Any question on YouTube? No question.
Okay. Anyway, I have a question. Again, thank you very much. Very interesting, many different things, and I like it a lot. I have questions in the part of the textiles. It's not clear for me. So the company is part of the technological center, or
no? What I was saying is that on case of textiles, so it was on energy storage. So it starts like high nano energy. So we start doing that on the lab, okay? And then we reach some point that we should decide if we go to another company, okay, to another startup, or if we could go for a technological center and try to disseminate this technology, okay? And on that case, this was the option, okay? So because it was, like I told you, like having a company is like climbing a mountain, okay? And so when you have experience in one, having two, it's hard, okay? And we already test and we know what are the challenge and so on. And one thing that is important on this, and this is for probably young students that are here, is that we need the motivation of them for doing these kind of things. For instance, to not have the problems that we have, like I show in nano energy, about getting seed money. Because when I start putting, if I say, okay, I can ask Sabatica to not work in the university, let's say during 3 years, but I put my salary and say to the seed capital, to the business angels, so you should pay me that. They just forget. There is no deal, okay? There is no deal about that. And so that's why I was saying that we need young people on this project. And telling the truth, at the beginning, iNano Energy, it was with 2 students also together. But then, because of money and about and other things, and people wants to go, for instance, to a PhD and so on, it diverged. So it's very important to have persons that wants to work on this at 100%, to be the head of the company, because it's more easy, okay? Being head of the company and are working on academies, sometimes it's hard. Sometimes it's hard.
No. And in the textile, going again to the textile, because I'm not in the energy and I don't have the numbers in my head, and I like to the numbers. So the power density that you were talking, because first you were talking about 550 microwatts per square meter, then 200 microwatts per square meter. How much really is needed to do something like the Bluetooth that you said, and in which range we are moving, or there are other technologies that are competing with this, or what is the values where needed?
Yes, first, highest to explain you, one good thing is that electronics needs are decreasing a lot, okay? It's not energy harvesting that are increasing, is electronics are decreasing, energy harvest are increasing, and then it's starting matching. Okay? It's a matching. Then the values, let's say, let's say 100 of microwatts, you can start doing things, okay? You can start just having like a temperature sensor sent by Bluetooth, like each, let's say 1 hour, 2 hours, a value for your mobile phone, okay? This is the type of thing that you can do. But it depends a lot on that. So like I told, like I say, if you saw what we were able to produce, for instance, on the oil and gas, it reduced a lot with temperature and pressure. But then, because they only need a signal each, let's say, 1 week, this could be enough, because they are accumulating energy in a storage, and then they just send the signal once for the data center. And this is the important part, is that depending on the kind of application, we need to test and do the prototyping of the energy harvesting. That's why I was saying that we do a lot of design thinking, like someone give us the problem and then we try to solve and say, oh, it's impossible. For instance, if you tell me, I want to charge my mobile phone with that shoe that we were producing, I will say that you really run a lot, like a lot of years, okay? You really need to run a lot of years just to charge your mobile phone once, okay? But this is the type of thing that's why I was saying, so it depends on the kind of application, and we need to adapt them. So that's why design thinking is something that at the beginning we were not on that way, but now we think that it's more for the customers is much more easy, okay? And I could say that nowadays we have a lot of IoT companies that try to contact us just because of that, okay? Because we have a facility to work with different technologies and all this stuff, and well, it's like that.
Yeah, that's the way. I mean, you have a problem and you have to solve that problem.
To solve. Yeah, since the university, from the first year, they give a problem and we need to solve it, even if it is with counts.
And the last question I have, just a curiosity. That's just curiosity about the blue energy. You saw this swimming pool with the waves. What is that? Or is it a specific center? I was curious about that.
No, this is a buoy. It's a buoy that is on the top, okay? And there are signalization on the buoy, okay? And so you
the place is there in Porto. The place for the
yes, it's in Porto. Yes, it's in Porto. So they are specialized on that, okay? So and they were the persons that came. So there was a company of boys. There are these guys from simulation of waves. There are another guys that do the prototype of the boys, and they came to us and say, well, we need this because we want to have, for instance, smart fishing, smart fishing, like know the fisher goes from here, but they know really where is the fish. And so this kind of stuff. Yeah, smart, yeah. Of course, it's always thinking on future, okay? It's probably not I could not go here near the sea and just go and have this type of sensors, but they are trying to do this kind of thing. Okay.
Okay. So thank you very much for the talk and for answering the questions, Andre.
Okay, you're welcome. You're welcome. It was really a pleasure, and this is I think that is sometimes it's nice to see this kind of projects and ideas. Okay. So thank you very much, Reyes, Clara, for all the invitation. It is always a pleasure. Okay. And if someone has some question, I didn't put my email, but you can ask Reyes, Clara, or some other persons that they know what is my email, and you can send asking. Okay.
Okay.
So thank you so much.
Thank you, Andre. Thank you for this very nice talk and very inspiring talk. I think.
Okay.
I think that for the students, especially, has been very, very nice.
Okay.
So shall we close the session, Reyes, here or?
Usually we do a picture because we cannot know, Marta. We cannot do a picture, make a picture in the real audience, but we can make a picture of the screen. So I ask the audience to please switch on the cameras. And at least,
come on.
Hassan, where are you? What you were doing?
Open the camera.
Yeah, sure. I'm curious why you didn't ask any questions.
Yeah, I was hoping that
you
students.
You are stressed because of the exams, or what is this?
Maybe they are very busy with.
My internet. Jose Mari, my internet is not working quite well, so she's not switching on the camera. Okay, that's what we have.
Okay, smile.
Okay.
Okay.
So,
perfect.
Yeah.
Perfect.
I hope we can in very few months, as quick as possible, meet in person, because
yeah, it's true.
It will be very nice. Yeah.
At some point.
Okay. At some point, yes.
At some point, for sure. Yeah,
for sure.
I wish I would go to Porto.
Yeah. You should come here in August, no?
I'm supposed to be in August, yeah. So let's say. Okay. So,
thank you.
Bye-bye. Thank you for attending the conference. Thank you, Andre.
Thank you very much.
Very nice.
Okay, thank you very much.
And have a nice evening.
Bye. Greetings to all the group there.
Yeah, okay. The same for all the people from
Okay.
Salas. Okay.
Bye.
Bye.
Okay. Bye-bye.